Which of the following graphs is the graph of an odd function? So here the key information is this. If f is odd, if a function is odd, then its graph is symmetric with respect to origin. Now, in the same way, we have a similar statement for even functions. If f is even, then its graph is symmetric with respect to y-axis. Now here it says f is odd, so we are looking for a symmetric graph with respect to origin. So now we can check. If you're checking for the symmetry with respect to origin, you take a point on the line, on the graph, then you take its symmetric reflection, its reflection through the origin, so it should be this, so it's not on the graph. So this is not symmetric with respect to origin. Now take this one, now look at the symmetry, it's a reflection through the origin, it's not on the graph. Now we can do this one, you take this one, so it's symmetric. If you take its reflection through the origin, so it means you're making a line through the origin from this point, and then you go the same distance on the other side, you come here and it's not on the graph. But when you take this one here, for example, take this one, when you make the reflection with respect to origin, then you get a point on the graph, and you can also take this point here to 4 here, so it has to go like, okay, so 2 units this side and 4 units up, so its reflection will go here. It's also on the graph, so you can check by picking points. So this is symmetric with respect to origin. It is symmetric with respect to origin. So you can say the f is here, f is odd. So these are the key facts here you have to know to solve this problem. Now consider the piecewise defined function f of x equal to square root of a negative x when x is less than -1, and x plus 2 when x is bigger than or equal to -1. Now, which of the following is the value of f of -4 and plus f of -1? So let's first evaluate f of -4. And how do you find it? So first, -4, you have to check. Like you set x equal to -4. Is it true? Like -4 less than -1? It's true. So it means you will use this formula here. So when you use this formula, you get -4, right? Instead of x, you see -4, and then there's this minus, so it will be square root plus 4, so it will make 2. And for the other one, now you set x equal to -1, and you check which condition is true. So x equal to -1, and then is it true, this one here, -1 less than -1? So it's false. -1 is not less than itself. So but here, if you put it here, you got -1 is bigger than or equal to -1. Is it true? Yes. So it's equal to, it's not bigger but equal to, so it says or, so it's fine, so it's true. So we use this formula here. So when you use this formula, you will get -1 cubed plus 2 is equal to -1 plus 2. So because this one is -1 again, and then this is 1. And when you add these two numbers, you get 3. If if a function f is even, then for every point CD on the graph of f, there exists another point on the graph in the form. Okay, it's basically it's asking about the property of the graph of an even function. So what do we learn? You know, in the first question, if f is even, then its graph is symmetric with respect to y-axis. Now, what does this mean? If you have a point, okay, if it is symmetric with respect to y-axis, so if you have such thing, you have such thing. If you have such thing, for example, you will have such thing here. So it might be different, you know, shapes, but okay, I will take one. Okay, assume this is your function, and then you have this. You will have its reflection through the y-axis here. But no, the idea here is if you have C, D, then of course its reflection through the y-axis will be on the graph. Okay, so assume this is our function. And you know, I told you the shapes might be different, but the idea is it will be symmetric with respect to. So it's something like this, I guess. I picked a very hard shape. So let's make it easy. So if you have this one, then you will have this one. So if it is CD, then its reflection with respect to a y-axis should be equal to minus C and D. So basically, if f is even, then if CD is on the graph, then this point here, minus CD, will be also on the graph. So if f is even and CD is on the graph, then minus CD should be also on the graph. So it says there exists another point on the graph in the form of minus CD. So the correct answer will be this. Now, the graph of f of x equal to square root of x is first vertically stretched by a factor 3. Now, assume you have a function square root of x, then you vertically stretch it by factor 3. Then this graph is reflected across the x-axis, and finally the graph is shifted by 4 units downward. Which of the following is the equation of the new graph? So that's a good question. First, we have to, okay, you know, each transformation is telling us some change in the formula. Now it says vertically, first let's write the transformation, vertically stretch by factor 3. Vertically stretch means that if you have f of y equal to f of x, then vertically stretch by factor c means y equal to c times f of x, and here c is bigger than 1. So in this case, so you remember this one, then this has to be what then? This has to be 3 times square root of x. Now we use this information here, and then the next thing is we have this graph is reflected across the x-axis, so it means the new graph is reflected through the x-axis. So here we have another one. It's reflect through the x-axis. So again, we want to find this function here. Now, reflection through the x-axis. Okay, this is, you remember this. How do we use this? I mean, where do we use reflection. If your function is if your function is changed to f of minus x, then we have this reflect through the x-axis issue. Sorry. This is not through the x-axis. It has to be minus f of x. Y. Okay, y. This is how I remember it. Like, for example, you have a function here, y is equal to f of x. You can take x here, and this its corresponding value is f of x. Okay. Now, if you take minus f of x, then if this is f of x, then this has to be minus f of x. So this point will come to this point at y, okay, when y is equal to negative f of x. So then if you see y is equal to f of x, now y is equal to minus f of x, then it means your reflection is across the x-axis. So if you see here, you see y is changing from positive to negative. So it's the height is becoming, it's reflected through the x-axis. So this is how I remember this issue. I look at y values. Y values are becoming plus to minus. So there's the reflection through the x-axis. So then this transformation, we have to change this function to minus f of x. So what happens here is it has to be minus 3 square root of x. Now, when it comes to the last step, it says shifted the graph, the resulting graph is shifted by 4 units down. So shift 4 units down. It means the changes on the y-axis again. So in which transformation we have this shift? Shift down, it's a vertical shift. So if a function is added or subtracted, then we have vertical shift. Y is f of x, and now 4 units down, it has to go down. So how many units? 4 units. So you can think of this way: y is changing, the height of a point is changing 4 units down. So it means f of x is going 4 units down. So it means here f of x is this one, and now f of x minus 4, it will be negative 3 squared of x minus 4. So we listed all the functions here, and the resulting function is this is the equation of the new graph. So it will be f of x equal to negative square root of x minus 4. So it has to be C. Which of the following is true for the function f of x equal to absolute value of x on minus infinity to 0? So to see such thing, like it says constant, decreasing, increasing, odd. So it's better you sketch the graph of this function. Now this is the absolute value of x is like a V shape here, like 7 in Arabic. And we are looking at this part of the graph. It's minus infinity to 0. So we are checking this part here. Now, what can you say about the behavior of the graph? Is it constant here? No. Is it decreasing? So when we say decreasing, we go from left to right. Decreasing and increasing issue is always from left to right. So you always check this way, not this way. So when you go from left to right, so what do you see? Your points are going down. So it means it's decreasing. So not increasing for sure. And the oddness, like if you want to check the oddness, it's easy, like take this point, and take its reflection through the origin, and this point is not on the graph, so directly it's not on. In the increasing issue, it's if it is decreasing, it cannot be increasing. Now, which of the following equations is not a function? Now, from the equation, it's not easy to see it's a function, but the basic idea is this here. I mean, you can use this approach. If you can isolate, I mean, if you solve, I mean, here, the main issue here is solve all these equations for y. So solve all equations for y. Now, if you, okay, first you will solve them, step 1. Then if you get something like y equal to a function of x, then you have a function. If you have plus minus a function, then this is not a function. Because for any x value, we will have plus minus 2y values, so this will not be a function. So let's try to solve all of them. Now let's see the steps here. Check y is equal to 6. Okay, I will be a little fast. 6 minus 2x divided by 3. And we have minus plus issue? No. So this makes a function. And now here you can, okay, send this one to the other side and send this one here. We'll get x squared minus 6x plus 5. And you see y, I mean, has always a value for any x. Okay, I mean, one y value for one x value. But let's try to solve this one. When you solve this one, you will get this one here. It's y squared equal to 16 minus y squared. When you solve this one, you will get 2 solutions here. So if you have plus and minus, you have 2 solutions. So when you put one x value, there will be plus and minus y values. So x will go to 2 y values, plus and minus 1, plus and minus values. And this makes it not function. So it doesn't make a function. So you say this is not a function. Now here, when you look at here, this is easily, like when you put an x value here, you get only one y value. So there's no 2 values. So this makes a function. So the answer here is C. Which of the following is the function of the graph shown below? Okay, now this function looks like an x squared, so this is not a well-stated function, but we will assume this looks like a parabola, and the basic parabola we know is x squared. So we will start with x squared. Start with x squared, y equal to x squared, because this is the one. This is the basic function we know. This is the basic function that has this behavior here. Okay, y equal to x squared. So if you take this one here, x squared, so by using some transformations, we will get this one here. How can you get this one? Now you can shift 2 units here, maybe 2 units. It will be like that. Then 3 units up. And then what? Okay, so we have to be careful here. How can we do it? Let's start from the x squared. We can, reflect. So this is y equal to x squared, then this is y equal to minus x squared. And shift this one 2 units, so it will come to this one here. So the shifting in the x-axis to the right, so it will be minus 2x squared. Then 3 units up, so it will be, this one will be then y equal to minus x minus 2 squared plus 3. I mean, you can find such a way to find the answer, but also if you want to go from the choices like do this like x squared, and then you can make this x plus 2 squared, shift left, and then makes minus x plus 2 squared, then make reflection through the x-axis, and then negative 3. I mean, you can check each of them like 3 units down. You can check. You can go one by one, but here it will be the answer will be you can check the choices, or you can directly start like me. You can try thinking what is applied to x squared, like which steps. You will try to go to that graph by using the transformations here. So the transformations that we learned. Which of the following functions is one-to-one? To check one-to-oneness, we have two ways we have learned so far. And one way is, I mean, we learned how to check the one-to-oneness on a restricted domain by making the graph. So the graph, in the graphs we use the horizontal line test. So you can use horizontal line test. So if a function is on a restricted domain, if your function graph is having this, or if it is passing the horizontal line test, so you say the function is one-to-one in this interval on I, let's say. But in here, if it is, after this interval, it might have, for example, after this, it might have this. So here, it's not one-to-one. Not one-to-one. So it means if you restrict this one to only one domain here, so then it's one-to-one. But if you take it overall, so it's not one-to-one. The horizontal line test is telling this. When you draw the horizontal lines, you get only one intersection, then it's a one-to-one line. You can also check worksheet 4.5. I mean, in the first problem, I already told this. Now let's sketch this one, x squared on minus 1. This is x squared, and minus 1 is here, and minus 1 to infinity. So it says I'm restricting my domain to this part. So I'm taking the picture, this frame here, this window. Now I'm taking only this part of the graph. So is this part one-to-one? Is it one-to-one? So horizontal line test says no. No, because the horizontal lines, when you draw a horizontal line, so it intersects at 2 points. So it says this is not one-to-one. Not one-to-one. Now let's look at the other one. This f of x equal to 1 minus x squared. Okay, 1 minus x squared, x squared will be like this, then minus x squared, then 1 plus 1, so it will go like this. Anyway, so it will go 1 up. So here is, let me tell, this is x squared, this is minus x squared, and then this is minus x squared plus 1, which comes to here. Anyway, we know now the graph of this function, and now on minus infinity to 3, so where is 3 here? So at 1 I think it makes 0, and minus 1 it makes 0. You can check, and at 3 when you put here it will be minus 8, so it will be something like this here. So but which domain it is, I mean, it's saying on this interval. So on this interval we'll look at here. So we are looking at this part of the graph here. So is it 1 to 1? Yeah, take a horizontal line, and if you find a horizontal line that passing through 2 points, it's not 1 to 1. So it's not 1 to 1, this is not 1 to 1. And you can check this one here also. The absolute value graph is easy. Now you can do this one, but which part I'm taking? It's minus 1 to infinity. So minus 1 to infinity is this part. So I'm taking the picture of graph on this part. Now look at here, we have this part, and when you draw a line, I mean, when you can find a horizontal line that passes through 2 points, I mean, that intersect with the graph at 2 points, so it's not 1 to 1. Not 1 to 1, sorry. And now when we come to this function, okay, let's see, this is the answer for sure, but let's see, let's verify it, let's justify. And here let's do the graph. The graph of this one here is the absolute value of x. Absolute value of x is this. 1 minus 1 means, make it to the right 1 unit. It will be 1 unit to the right. And now we are talking about 1 and infinity here. So this part here, 1 infinity. So we are looking at this window here, this picture of the graph. So is it 1 to 1 here? For any horizontal line here, we see this is only intersecting at 1 point. So it's f is 1 to 1 on 1 to infinity. So this is the answer here. Which of the following is the inverse function g inverse of the function gx? In this type of questions, we have a method. There are 2 methods or 3 methods. It depends on your background. And here in the university, I mean, in prep school, we teach this way. You set y equal to 2x minus 1 cubed plus 2. Okay, then you solve it for x. It means you get x equal to something here. So you isolate x here. So our goal is this. Now you send 2 to the other side, you get 2x minus 1 cubed. And then how can you get rid of this cube? So you take the cube root of both sides. And the cube root of cube since it's odd number here, odd, you don't have the absolute value. You directly write 2x minus 1. That will be cube root of y minus 2 on this side. And send 1 to the other side. And divide by 2. So you will get x. Now this was step 1. And step 2 here is change x to f inverse of x and change y to x. So in this case, it will be, this one will be cube root of x minus 2 plus 1 divided by 2 is equal to f inverse of x. So this will be, which one is it? It's D then. I think some of you might do like this x, y changing issue at the beginning and then solve it for y and do y change to f inverse. You can do that like in high school. Most of you learned it this way, but here we use this method. I mean, it's okay as long as you get the correct answer. It's okay, and even in the essay problems you can do that. The f of x equal to this function and gx is this function. Which of the following is the formula for f minus g of x? Now f minus g of x is defined as f of x minus g of x. And what is f of x? This is 5x plus 1 divided by 2x minus 3. And g of x is 3 minus 2x. Here 7 minus 2x. Now we have to make the denominators common. Okay, we have to make them same. They're not same, but here there's one important thing to notice. If you notice this one, 2x minus 3 is equal to minus 3 minus 2x, or you can say 3 minus 2x is equal to minus 2x minus 3. I mean, this is coming from the fact that this a minus b is equal to, you need minus b minus a. So you can do it, and you can see it's minus b plus a, and then you can change their places, their order, if you stick to the signs, so you get this one. Now I want to use the second one. Okay, I will get this one here. I want to use this one. I will change the second one as minus 2x minus 3 here, and that will be 7 minus x. And one other thing I will do is this one here. This fraction here, we have property. Like if a over b, if you have a over minus b, then you can write it as minus a over b, or you can write, so you can take this one to here or here. Okay, so it means you can write it as this minus a over b or minus a over b. So you can use this one or this one if it is given this way. Now I will bring it to here, so I will get this minus 6 minus 7x over 2x minus 1, 2x minus 3. Then this minus and minus here, it will make plus, so I will end up with this. And then you can add them now, so you will end up with 2x minus 3 in the denominator, and 5x minus 7x, it will be minus 2x, 1 plus 6, it will be 7. Now let's check them, the denominators. Okay, here, and the denominator is here, but it's 12 and 12 here, so we have to do some more thing here, because maybe if we multiply the fraction, I mean both sides, both numerator and the denominator by minus 1, then you will get an equivalent fraction. So what I mean here is this, like sometimes, if you have 1 over 2, you can get like 2 over 4 is given, you have to choose this one, or it is given minus 1 over minus 2. So these are all same, right? So if you don't see this one in the choices, but if you see it in the choices, then you will choose this one. So this might happen here. Let's see. Okay, let's try to do some tricks here. then I can multiply both sides with minus. So it will be the same. So the mathematical value will not change. The value of the fraction will not change, but just the appearance. And this will be plus 2x, and then minus 7 divided by minus 2x plus 3. And you can switch their places here, 3 minus 2x and 2x minus 7. So now it looks a okay. Here the important part is to see this one here. I mean, if you see this one, this is much more easier. I mean, if you don't see, then you will try to multiply with 3 minus 2x and 2 minus 2x minus 3, and it will mess up the things. Yes, at the end you will get an expression that is equivalent to one of these, I mean, to the correct answer, but you have to do lots of simplification at the end. Now, which of the following is the domain and the range of the following function? So how do we find the domain here? The domain is the reflection. Okay, since you have an arrow, so it means it goes like this, so it goes endless. So when you look at, so if you want to get the domain here, you'll look at the projection of the point on the graph onto the x-axis. So this will make, okay, since I'm putting this because of this, arrow here, so there will be no end for it. So I put minus infinity. So this part will be my domain. So domain will be now minus infinity 0. 0 is included because of this here. It's filled. So there's no, not 0. Sorry, this is 1. So 1 is included because at 1 the function has a point. So this is domain. And what about the range? The range is the projection of the points on the graph onto the y-axis. So it will be the projection of the graph onto the y-axis. So then you take this one and project this. So take these points and project them onto y. So this is also filled, so 0 is included, and all the other points are included. So this will be the range here. So it will be from 0 to infinity, and 0 is included here. So the answer is, okay, it's A. Which of the following is the expression of the function graphed below? Okay, there are two ways to solve this problem. One is going from the choices, and the other is from, directly you can find these equations here. Now, I will do the equation part. I mean, checking the fraction, checking them, I mean, you can do it. And checking them, it doesn't look very easy here. Okay, what I will do here is you'll find the equation of this graph, this one here, this part, and you will find the equation of this line. So these are lines, right? These are lines. So we need to find the line equations here. So how can you find the line equations? Especially we want y equal to, okay, we have to write them as y equal to mx plus b form. Now the first thing here is, the easy part is this one here. This is a horizontal line. Horizontal line. A horizontal line is in this form all the time. So y equal to something. And this y is this value on the y-axis, this level, this is minus 2, right? So I will say this is the horizontal line, y equal to minus 2, because it passes through here 1 minus 2, for example. And here 3 minus 2. So as you see, minus 2 is always same. So y is equal to minus 2 line. And here, this part, you can take 2 points here. Take this 2 points here, minus 3 and 4. Yes. This one is minus 2, 2. Okay. Then find the slope. This will be, okay, I mean, you can do this. 4 minus 2 divided by -3, -2, so you end up with 2 over -1, which is -2. So I can say the slope here is -2. Then we can write, okay, we can use the slope point form. This is a point on the line, so I can use the slope point. So this will be y minus 2 is equal to -2 times x minus -2. Then this will give you y minus 2 is equal to -2x plus minus, so it will be -4. And if you arrange them, it will be y equal to -2x minus 2. So we have this graph here, this -2x minus 2. It's the graph of this line, and this is the graph of this line. But now we will put the conditions on x here, and then it will cut the graph. So we will take the pieces of the graphs. So for x less than, so for this part here, for this part, so it means x less than or equal to -2. At -2 we have a point filled by the graph. So what is this? What's the equation for this part of the graph? This is -2x minus 2. So for this part, I will say -2 minus 2, -2x minus 2. This is not, and this is not. Okay. And look at this graph here. This is -2 on this part. X is bigger than not equal to, because this is empty. So it will be y equal to -2. Y equal to -2 for x if x is bigger than -2. So you can say this y is always a function. It's a f of x equal to -2 if x is bigger than -2. So if x is bigger than -2, we have -2. And here there is no equality, okay? And here there should be equality. So we take this one, b. Now, f of x equal to this function and gx is this one. Which of the following is the formula for g of f of x, or g composition f of x? Now, here the formula for this is g of f of x. Now, what is the formula for f of x? It's square root of x minus 3. And now g is, okay, what is g? G is this one, and we want to find square root of x minus 3. So instead of x, we see this one. You will write the same thing here, squared plus 5, so it will be x minus 3 plus 5, so it will be x plus 2. So you can say this is square root -3 square root of x minus 3, take the square plus 2, so that will be x minus 3 plus 2, which is x minus, no, sorry, this is 5. So this is 5, so it has to be x plus 2. Which of the following images depicts means like shows, let's say, or describes the graph of a function as a solid curve. So this is the solid curve, is this one is the solid curve here, solid curve. This is the solid curve. This is a solid curve here. Solid. And the graph of inverse function dashed curve. This is dashed curve. So solid means like this, and dashed here, it's this with the dashes. So here dashed, these are all dashed. Okay, now we know what is solid and what is dashed. Now it says the following, which of the following shows the function itself as a solid curve and its inverse dashed curve. So now this is, if this is f of x, then this has to be the inverse of it. So is it true, by the way? So what is the relation between the graph of f of x and f inverse? So this is the key information here. So if you know this information, we can solve this problem. Okay, I will keep this one here. The solid means this, and dashed means this. Now the information, the very important information is this: the graphs of y equal to f of x and its inverse, or y equal to f inverse of x, are symmetric with respect to y equal to x line. So in this case, we have to first find the y equal to x line. Now look at here, what is y equal to x line? The y equal to x line is always this line here. Y equal to x line is, you take 0, minus 1, like 1, 1. So this is always the one. It goes all the time, like it makes 45 degree here, 45 degrees. So it equally divides the quadrant, and it goes this way. Now you draw this one, you draw this line, you draw this line, and you look if the solid line is, they're symmetric with respect to each other. I mean, symmetric with respect to the y equal to x line. So as you see, these points here, they are symmetric with respect to this line here. So this is correct. So this is y is equal to f of x, and this is equal to f inverse of x. But when you look at here, when you look at its reflection, so it has to be like that, and this is not it. And if you look at here, its reflection should be like that. It's not it. And the reflection of this one should be, or its symmetry should be something like this, not this one. So only symmetric functions are those here. These the graphs are those with respect to y equal to x line. So these are making the inverse functions. What is the domain of the following functions? Okay, now I will try to write them as formal as possible. So the domain of a function, domain of f, is the set of x values, real numbers, such that this is not undefined, or we say a real number. So it has to be a real number. So how can you check? So what makes it undefined? So the condition here is this: x should be all real numbers such that, what makes the problem? So this makes, if it is 0, it makes a problem. Negative is 0, negative makes a problem. So you say the condition here is x should be, 2x should be bigger than 0. Then we solve this one. When you solve this one, you basically get x bigger than 3 over 2. Then you end up with x, I mean, as an interval, you say 3 over 2 to infinity. So you can say this will be 3 over 2 to infinity. Now, the same thing goes for the other function here. Okay, the domain of f is all the real numbers such that minus 2 over x squared plus 8x minus 9 is a real number. when it's not a real number, it's not defined if the denominator is 0. So we say all the x numbers are accepted except the ones that makes the denominator equal to 0. So you say all the real numbers except these, except except one makes the denominator 0. So find the zeros here, -9 and -1. So -1 and -9 and 1. So you say all the real numbers except -9 and 1. You can say all the real numbers except -9 and 1, or you can write this way. I mean, if you want to check it, if you want to write it as an interval, you can say all real numbers except -9 and 1. So then you write this interval here. So what is it? It's -infinity to -9 union -9 to 1, and then union 1 to infinity. Now, when it comes to the last one, we want all the real numbers. That makes this expression a real number. So the condition, the square root gives this condition: x should be a real number, but also the expression under the square root should be bigger than or equal to 0. Now it comes to solving this equation here. So how do you solve such equality here? This is in standard form, and then let's solve this inequality. Now first, you'll make it equal to 0 and solve for x. Now you can use quadratic formula, minus b, which is -1 here, plus minus square root b squared, which is 1 squared, minus 4 times a is 1. 1, 1, 1, we have a, b, c, and it will be 1 here, so divided by 2 times 1, so it will be -1 plus minus square root -3 divided by 2. So now, as you see here, this is not a real number. So the roots here are not real. So what you get from here is this. There is no real root for this equation. Now, so we didn't find, okay, this was step 1, step 2, step 3, we have to do the real line. Now, since there's no real root for it, we just take a number here, take 0 and put it here in this expression, this polynomial, and you got 0 squared plus 1 is equal to 1, so which is plus, is bigger than 0, so you write here plus. Now, what is the solution set? We want the positives wanted and the roots wanted. No root, but the positive intervals wanted. and the root wanted also, but there is no root, real root, so I don't consider the roots. I don't think about the roots because there's no root here, no real root. The positive interval is from minus infinity to positive infinity. So when you solve this one, the solution of this problem is minus infinity to infinity. Now the domain turns out to be minus infinity to infinity, or you can say all real numbers or all real line. Of okay, let f be the function of which the graph is given below. Okay, it's better we say this graph is, this is the graph of, okay, this is the graph of y equal to f of x. Now, complete the following statements. The domain of f, so domain of f will be the projection of the graph of the function onto the x-axis. Now you take them. Now, as you see, it will be, okay, this is not ending, so it goes endless. So when you take, you will see this, all x's are in the domain of the function, so you say it's all real numbers. Or you can say minus infinity to infinity as an interval. Now, when you look at the range, so you take the intersection of, not the intersection, you take the projection of all the points of the graph onto the y-axis. So you can go up to here. The least one is minus, what is it? This is minus 8. Yeah, this is minus 8. And when you take the projections here, here it's minus 8. But let's look at this part here. It goes endless here. So it covers everything on the y-axis. So the after minus 8, we don't stop at minus 8. We keep going. And this is still happening. This is the projection still. So it will be all the y values here. So it will be all the real numbers. So again, the domain will be minus infinity to infinity, and the range is minus infinity to infinity. And now f is increasing, okay, decreasing from left to right. So from left to right, it's decreasing. And here it's increasing, and here it's again increasing, and then here it's decreasing, right? So decreasing from where to where you go, it's minus infinity to minus 2 union, okay, 2 to infinity, and increasing on which part? Minus 2 to 2 here, this part. Now let f be the function. Okay, here's y equal to f of x. This is the graph of y equal to f of x. Find the expression of piecewise defined function. Now we look at the behavior, different behaviors here. There's a line here. There's a line behavior, and this is the graph of. This one is the graph of a basic function. If you think of it, we have, okay, do we have some clue? Yes, minus 2, 8, minus 8, and 2, 8, and 0, 0. Okay, now think of this function here. We have 0, 0. When you put minus 8, you got minus 8, minus 2, and you got minus 8. When you put 2, you got 8. So which function is this? So if you put this x values you got, as you see, this is cube. So y will be the cube of it. Cube of the x value. So this is basically, this part here is y equal to x cubed. And now after 2, we have this line here. So if you want to write the equation, if you want to write the formula for the piecewise defined function, you have to write the formulas of this line, the equation. So for this line, what is the equation you have to find? For this one, we have some idea y is equal to x cubed for this part. And for this part, what is it? Now, for this line, let's find the slope. Okay, what's the slope? We have minus 2, 8. Okay, one point is minus 2, minus 8. And the other point is minus 3 and 0. The slope will be then 0 minus minus 8 divided by minus 3 minus minus 2, which is 8 over minus 1, which is minus 8. Now, the slope of this line is minus 8. Now, the question here is, can we find the equation of this? Yes, we can use this approach. Y is equal to minus 8x plus b. And negative 3, 0 is a point on the line. So I can put this here 0, and this is minus 8 times minus 3 plus b, and b turns out to be here, it's plus 24. So the other side, it goes minus 24. So we end up with this y is equal to negative 8x plus, no, it's, okay, plus minus 24, which makes minus 24. So this is the equation of the first line here. Now, the important thing is you try to find everything in terms of, as y equal to, and y equal to. This is important. Now, for the second line, we have the same issue, find the slope, and you try to find y equal to mx plus b line, mx plus b. Okay, let's check. And we take 2 points here. This is 1 and 2, 8. Okay, 2, 8 is on the graph, and then we take this one, 3, 0. These are given on the graph. Now, what's the slope? Okay, I will take 8 minus 0 divided by, and 2 minus 3, which is minus 8 again. Okay, the slope of this line is now minus 8. And I can use y equal to minus 8x plus b. And I use this point here, 3, 0. It means when I put 3 here, I will get y equal to 0, and this says b has to be 24. So now my equation for this line will be equal to y equal to minus 8x plus 24, and this will be okay, this will be the graph of this will be the equation of this one here. Now, when writing this function here, now we have three different behaviors here. One is when x is less than minus 2. If x is less than or equal to minus 2, you check here if it is filled, so then you can take the equality here. So this is filled here, there's no problem, so it's minus 2 is included. Now, you write this one here, this part of the equation here as negative 8x minus 24. And for this one, from minus 2 to 2, and 2 is also included. Now, if x is included, one of the intervals, no need to write this one with the inequality. With the equality, sorry. So I will say this one is x cubed, Now, if x is bigger than or equal to 2, or I mean, this is included in this part, so I will not include it here. X bigger than 2, so this will be negative 8x plus 24. So this is how we write this function. So basically, try to get the equation of each curve or each line by using the line equation and the other information we used, or the basic curves. Then find them this way. Then for each interval, put them here. So this gives you the piecewise defined function. Now the graph of f of x is given below. Match each equation with its graph. Now this is f of x. I mean, this is the main graph. Now, how do you, okay, what should you do to get 3? Okay, now let's see. This is shifted 1, 2, 3, 4, 4 units. 4 units, right? It gives number 3. Okay, so if this is f of x, if you want to get 4 units, right, so you have to have this f of x minus 4. So shift x 4 units, like to shift the function 4 units, right, means f of x minus 4, change x with x minus 4. And this will give you the third one, which is here, 3. Now, so do we have some vertical shifting? Yes, for example, here is 1, 2, 3. So we go 3 units up here, 3 units up. So it will give us the f of x will become y equal to f of x plus 3. So then we will get 1, so which is 1. Okay. Now let's look at the other two. Now, and here, the first, it goes like 1, 2, 3, 4, 5, 6 units. 6 units left. So 6 units left means f of x becomes f of x plus 6. But the thing is, now it's stretched horizontally a little bit, you know. Now, so for this reason, oh, so hold on, not, is it? No, oh, okay, it's not. So basically this one here, when you, okay, let's go. Let's do this stretching here. Not stretching, but let's do only shifting here. So if you shift, you got this one. Now what happened to this? It was 1, the height, now it became 2. It was 3, it becomes 6. So the height all the time doubles. So if it was f of x, this becomes 2 times f of x. So it means this function after this, it is multiplied with 2 times f of x plus 6. So you see here a vertical stretching. So that will be, the 2 will correspond to this one. And the only option for this one will be here. Let's see how this is effect is minus. So with minus we have this. We go, okay, we take the projection, we take the reflection through the y-axis. This makes y equal to minus f of x. Then as you see, it is suppressed or compressed or shrink horizontally then. So it means it shrunk by 2 units here. 3 becomes here 1.5, and then this becomes, so it tells us we have the fourth transformation. So the stretchings are a little difficult to see, like it is vertical or horizontal. Sometimes it's hard to see. And you can try to check the distances here, like on the x-axis, if it doubles or like makes it half, or it's vertically, it doesn't make half or, you know, double. So you have to pay attention to it. Now let's look at this problem. It says find the domain of f plus g. So the first question is easy. It's f of x plus g of x. So which is x plus 1 over x minus 1, x plus 1 over x minus 1 plus 4x over x minus 3. If it's an essay problem, I mean, if it is, if more is not asked, like you don't have to combine this one. Try to focus on the domain. So what's the domain of these two functions? So the domain of f plus g is, we know it will be domain of f intersection domain of g. So what's the domain of this one? The domain of this one will be all real numbers except 1. And here the domain will be all real numbers except 3. So how do you check the intersection here? So all real numbers except 1 is this. And the all real numbers except 3 is this. So you check the projection, you check the intersection, mushtarak part, so check the common part. So what you get here is from minus infinity, like if you draw it, the intersection will give you this one. 1, 3. So this will be our set, and the domain will be here, the domain of f plus g is equal to minus infinity to 1, union 1 to 3, and union 3 to infinity. So we write these 3 intervals. Now, when it comes to here, again, the domain of f times g is equal to domain of f intersection domain of g. And here we know this is the domain of f is all real numbers except 1, intersection all real numbers except 3. You know, in the previous one, I mean, we find the same thing here. We'll get all the real numbers except 1, 3, or we can say here it's minus infinity to 1, and 1 to 3, and 3 to infinity. So it's, you know, I want to remind you this one. Domain of f plus g, and domain of f times g, and the domain of f minus g, they're all same, and they are the intersection of domain of f and the intersection domain of g. So I found this one, and I intersect, and I got the domain of these functions. So they're same. So the answer for them is same, except this one. This one is f times g, x is equal to x plus 1 times x minus 1 times, or x times x minus 3. But you can combine and you can do this expansion here, but maybe no need. Well, there's no need for now. I mean, yes. Now the domain of f of g. Here, the domain of f over g is indeed equal to the domain of f intersection domain of g minus zeros of g. Now, this part we already know that it's that part here. Now, what is the zeros of g? Now, zeros of g are the x values making gx equal to 0. So you set gx equal to 0, and for x over x minus 3 equal to 0, then what does this mean? You multiply both sides with x minus 3, you have 0 times x minus 3, and then you got 4x equal to 0, and x turns out to be 0. Then you check the denominator. Does it make a problem in the denominator? No. So x equal to 0. So zeros of g is only 0. Now we do this one now. This part we already know. It's I want to show this one as okay. I want you to understand how to remove 0 of g, which is only 0 here. Now this is the set we know from the first two parts here. That will be minus infinity to 1 to 3, and then 3 to infinity. We're talking about this part. And you remove 0 from here because the 0 of g is 0. And then you remove from 0 from this set, and you will end up with this. Now if you remove 0, then you will get 0, 1, and 3. So the domain will be here. The domain will be equal to minus infinity to 0, union 0 to 1, union 1 to 3, union 3 to infinity. And also, if you want to write, this is also okay. Like you can also say this all real numbers except 0, 1, and 3. And one other thing this I forgot to tell you is f over gx is so since in the question we have to answer this, so it will be f of x over g of x, and this will be f of x plus 1 over x minus 1. You know, sometimes I will write this way. You can write it this way. Then you can multiply, flip and multiply. I mean, if you want to go further, and you can do this multiplication and get the results. But this is the answer here. And this was the answer for the domain, and this is for f over g of x. Now it says find f composition g of x. So we can directly do it here. f g of x, which is f of x squared plus 2. And now here, how can you do that? X changed with, replaced by x squared plus 1, x squared plus 2. So you have to do it here. So this will give you x squared plus 2 minus 1, which is x squared, square root of x squared plus 1. Now, it says find f inverse. Now you write y is equal to square root of x minus 1. And you take y squared and make it x minus 1, and y squared plus 1 equal to x. Then change. Okay, this was the first step, step 1. Then step 2, you change y with x and f inverse with. So you change x with f inverse of x. Then this will give you x squared plus 1 equal to f inverse of x. Okay, so it says checking. You have to check two things here. The first thing is you have to check f of f inverse is equal to x. So you will check this one, and let's check it. What is f inverse here? F x squared plus 1. So you write here f of x squared plus 1, and this will become x squared plus 1 minus 1, and you will end up with this x. So I think one thing is missing here. This is x should be here bigger than 0, so it has to be x. Now, so we have to put this condition like x is bigger than 0. And here we take this one, we check this one here, f inverse of f of x. So x. Now let's do it. F inverse of f of x, which is x minus 1, square root of x minus 1, and this becomes square root of x minus 1 squared plus 1, and this will give you x minus 1 plus 1, so it's equal to x. Of course, here we assume x is bigger than 1. So here, these requirements are, okay, we found it. Here it's about the domain here. The domain of f is, x is bigger than 1, and the domain here, no problem, it's all real numbers. But when you try to look at the range of this function here, it will be just positive numbers. So we have this positive numbers here in the inverse. Okay, that's it.